from x plus 2 minus x squared dx. So I have x squared over 2 plus 2x minus x to the third over 3 from -1 to 2. So you plug in 2, 4 divided by 2 is 2, and plus 4 minus 8/3, and minus, when I plug in -1, 1/2 minus 2 plus 1/3. If you want to leave it like this, I'm fine. You do not need to do the arithmetic, and I'm not interested in an approximation from the calculator. If you stop here, you get, and this is correct, you have full credit. I don't need the arithmetic and waste time, because I'm assuming at this point everyone can add fractions and subtract them. So I'm fine with this. You don't have to find a final answer. You can stop here. I'm fine. But please understand, without graphing, without showing where the area is, without finding the points of intersection, and then writing the integral, you don't have to write above and below. Once you show me x plus 2 minus x squared, then I know you know what you're talking about. And determine the antiderivative, -2 to 2 to -1 to 2, plug them in like this, and you can stop and move on to the next problem. I'm fine. That's it. So, definite and indefinite integrals and potential substitution, approximating the area with the leftmost point or rightmost point. Given R prime, to find R or total revenue. When it says total revenue or total cost or total profit, you have an integral. And of course, I'm here with you, so you can ask. And areas we just looked at. Consumer surplus, producer surplus, please have ready the formulas and what they mean, so you don't make a mistake on which one you subtract and which one you add. One quick question about this. So there may be just two simple differential equations. This is a piece of cake, right? This is a piece of cake, should be, because you're using the calculator. This is cumbersome because you have to go through a few steps, but it shouldn't be a problem. And how to find the domain. And these are already in the D-test anyway. We still have time, a few minutes. So do you want to choose anything else from here?
Could you go over a differential equation example again?
Yes, absolutely. Perfect. That was 5.7. I'm just looking to find the page number. That's 535. And that is my page 10. Okay, so I don't know. Let's look at 37. If we did 37, stop me, please. So dy over dx equals 7 over y squared. Now, what if I'm given this?
Yes, we did that question.
We did?
Did you different?
Yes. We did?
Yes.
Okay, so let's do 33. So in 33, we have 3y squared dy over dx equals 5x. So remember, we are trying to separate the variables here. We are looking to find y, but we have to separate the variables. 3 is okay, y is okay, dy is okay, dx is not okay, so I will multiply both sides by dx. So 3y squared dy equals 5x dx. Now x is alone on one side, y is alone on the other. I'm in business, so I integrate. This is 3y cubed over 3, and this is 5x squared over 2 plus a constant c. Of course, these would go away. So I have y to the third equals 5/2 x squared plus c, All I have to do to solve for y is apply the cube root, and it's done. That's all I'm asked to find. Now, if it's squared and I take the square root, I have to write plus or minus the square root. But it's the cube root. The cube root does not have plus or minus. The square root does. Is this okay?
Yeah. And we only need one constant because
On one constant, because remember, if I have here 5 and I have here 7, then I move it and I have 2.
okay.
It doesn't matter. So we only use one. Now, what if the problem is written like this? Because dy over dx is y prime. Then I have to rewrite it. Because I know that y prime is always the same thing with dy over dx. So they may try to trick me and put y prime and say, solve a differential equation. Oh, wait a minute. Y prime has to be replaced by dy over dx first. And then I separate the variables and I go step by step.
Could you repeat that one more time?
Yes. So if I'm given the differential equation written like this, I will have to say, oh, they are trying to trick me because this is dy over dx. And then I continue as I just did. But first I replace y prime by dy over dx.
Okay.
Okay, let's look at one more in which we are given a initial condition. So for example, 41, because I want us to have an example like that. We had it in the notes in the class, but let's also look at, we still have time. So let's say, see, y prime equals 5y to negative 2, and they were telling us that y of 2 is 3. Okay, so this is tricky. What are they telling me? They're telling me that dy over dx equals 5 over y squared. I'm going to cross multiply. Y squared dy equals 5 dx. Completely separated. Y is on one side, x is on the other. Okay, done. So y to the third over 3 equals 5x plus a constant c. Now I plug in my condition to find c. It says that y is 3 cubed over 3, when x is 2. When x is 2, y is 3. 27 over 3, so that's 9. 5 times 2 is 10, plus c. So then c must be negative 1. So I go back, plug it in. So I have y to the third over 3 equals 5x minus 1. I multiply by 3 first, and then I apply the cube root. So I get y equals the cube root of 15x minus 3. In case I'm given a condition, an initial condition. Again, what does this mean? Ah, they're trying to trick us. What does this mean? 1 over. Cross multiply to separate the variables and integrate both sides. When I integrate this, I get this. When I integrate this, I get this with a constant c. But now I can stop and say, oh, when x is 2, y is 3. So 9 equals 10 plus c. So then c must be negative 1. When I move 10 to the other side, 9 minus 10. I put it back in. I have y to the third over 3 equals 5x minus 1. I'm solving for y. Multiply both sides by 3 and take the cube root. Done. No plus or minus for the cube root, only for the square root.